Welcome to Chapter 4.1, Introduction to Quadratic Functions and Transformations. So what we would need to do, we have a parent function, if you remember, y equals x squared. We need to use a table of values, and we need to graph this. First thing we need to think about is, and which is probably, if you notice to the left here, we have a vertex. Okay. In other words, we're going to ask ourselves, what can we plug in for x to make it 0? And that's 0. So if we plug in 0, we get 0 squared, which is 0, so therefore y equals 0. Okay, that's going to be our starting point. Now what we can do, if you remember that all x squares, these are called quadratic functions. Okay, so f of x equals ax squared plus bx plus c. If we remember what does a graph of a quadratic function look like, it is a U shape, or we call it a parabola. So it has symmetry, kind of a mirror image. So what we can do is if we find the vertex, and then we just do 4 more points, 2 above 0 and 2 below 0. So I'll choose 1 and 2, and then -1 and -2. Okay, input 2 in for x, and you get y equals 2 squared, which is 4. Also, if you plug in -2 and square it, we get 4. So you can see the symmetry, both 4 and 4. And if we plug in 1 and -1, you will get 1. So what we can do is we can graph this. We can go to 0, 0. There's our vertex. We can go over 1, up 1. Another point. Over -1, up 1. Another point. We can go over -2 and up 1, 2, 3, 4. And then over 2 and up 1, 2, 3, 4. And then we can draw our parabola. If we continue this, we would see that hopefully 3 and -3 equal 9. And they would be on our graph. Now, a couple things that we need to know about a parabola. Okay, what properties do they have? Well, it has a max or a min. Notice the graph that we drew has a low point where the vertex is, so that's a minimum. If it were upside down, or dumping all the basket out, then it has a maximum. So where is the min and the max value? It is where the y coordinate of the vertex. Whatever our vertex is, in this case, our vertex was 0, 0. That min or that max is right here where the y equals. So that y equals 0. Okay. It also has an axis of symmetry. Now the axis of symmetry, if you notice, I'm going to draw this dotted line right here. Okay. This axis of symmetry, it goes through the point that divides the parabola in half. Okay. Well, what value does that go through? We use that as an x. So it goes through x equals 0. That's where we get our axis of symmetry. It is a line. Okay, it's a vertical line. The vertical lines are always x equals. Okay, domain and range. We're going to ask ourselves, what possible values can I put in for x? Left negative or right positive? And if you notice, the domain for all parabolas will always be all real numbers. So it's a little fancy way of writing all real numbers, the set. Okay, but the range, now notice on our function, it is everything greater than 0. It could be everything less than 0. Okay, so the way we translate that is we have a min or a max. Whatever the minimum is, it's going to be all the y's that are greater than or equal to the min, or all the y's that are less than or equal to the max. Based on a couple of functions that we have, we want to ask ourselves, is it a quadratic? If it is a quadratic, we need to write it in form ax squared plus bx plus c. We need to graph the quadratic. We need to know, does it open up or down, which you might want to do first. And then, is the y coordinate of the vertex a max or a min? And then find the vertex and the axes of symmetry, the AOS. Okay. So the first thing, how do we know if things are quadratics? We look at the x value. Our x is a square, so yes, it is a quadratic. Yes. Okay, now we need to write it in form of ax squared plus bx plus c, if possible. So we start with our function, f of x equals 1/2 x squared minus 3. It is in that form. What's missing? That bx, so therefore the bx is actually 0. In other words, another way we can look at it as f of x equals 1/2 x squared plus 0x minus 3. If we need to label which we will, we'll need to label the coefficients a, b, and c. We'll say a is 1/2, b is 0, and c is -3. Before we graph the quadratic, let's actually move to, does it open up or down? Well, what tells us that it opens up or down is we need to look at the a value. So look at the a. If the a is positive, it opens up. If the a is negative, it opens down. So in our case, ours is going to open up. And then now to graph this, really this is a shift. If you remember, the parent function starts here at 0, 0, and then work this way, work this way, this way. So based on chapter 2, when we had a translation, okay, what's happening? Well, think outside the x squared. We have a -3. So we know that the vertex is going to go down 3. So 1, 2, 3. So we have down 3. Now, what is that multiplied factor, that 1/2, going to do? Well, that's the stretch part. Or is it going to stretch or compress? Well, it's less than 1. So if we remember a is less than 1, it's going to be a compression. So what we're going to get is, we're going to get this to be a little wider than what we were used to. So our translation is going to go down 3, and it's wider by a factor of 1/2. Now moving on to the last one, we have to look at, well, we need to know, is the y-coordinate a vertex, a max, or a min? Well, if we look, our graph moves up, so we have a minimum value, and our vertex is 0, -3. So 0, -3, we know it's a minimum of -3. And then the last thing is, we know that it has an axis of symmetry. Okay? The axis of symmetry goes right through this middle. What point does it go through? It goes through, if you look on the green one, it goes through 0, -3. So if we look at our vertex, the axis of symmetry is at that x value. So our axis of symmetry is x equals 0. Next one, g of x. If we take g of x, we need to rewrite it if it is a quadratic function in ax squared plus bx plus c. Well, it is squared, so we know it's going to be a quadratic. There is no other x's that we're multiplying. So if we start, I'm going to start here by multiplying an x plus 3 times an x plus 3. So you'll get g of x equals -2, and then this is x squared plus 6x plus 9. And then we have a plus 1 on the end. Distribute the -2 through, and we get -2x squared minus 12x minus 18 plus 1. Combine like terms, and our function is g of x equals -2x squared minus 12x minus 17. A equals -2, B equals -12, and C equals -17. If we look at the A term is -2, therefore we know this is going to go down. And what we need to do, if we look at the translation, let's go back to the original function. If you see the 1 here, we know our vertex from the parent function, from that blue dotted graph, is going to move up. Okay. We also know that it's going to go, if we think about this, where's the vertex? We need to ask ourselves, what goes in here to make this 0? So x plus 3, what makes x plus 3 0? -3. So our vertex is -3. And then when you plug in -3, you get 0. -2 times 0 is 0. So 0 plus 1 is 1. So you get -3, positive 1. So if I jump way over here to the end, there's my vertex, -3, 1. So we go on the graph. We go over -3. We go up to 1. We know it moves down, so it's going to look something as a quick sketch like this. So we can say left 3, down 1, and then if we also notice on the A term here, our A term is a -2 or a 2, which is a stretch factor. So we're going to use a narrow. So narrow by a factor of... So that takes care of our graph. We know it goes down. Is it a minimum or maximum? Well, the vertex is at the top of the parabola, so we know that that is a maximum. So it's a max of what? It's a max of 1, so that y value. The other thing we know is that the axis of symmetry always goes through the x. Which x value does it go through? If you look at the vertex, it goes through -3. So x equals -3. Next problem. Okay, we have parentheses, we have a couple x's, so we're going to have to simplify a little bit. If we multiply, you get -4x cubed minus 20x. If we look here, this is not a squared, it is cubic. So is this a quadratic? No. Forego the rest of the problem. Hey, that's easy. Okay. If we get to the bottom one, we have 3 times the quantity. There's no x on the outside. This is a squared, so yes, this is a quadratic. Okay. Hit pause, fill out the rest of the squares, and we'll check back with you in a second. Alright, welcome back. Yes, it was a quadratic. If we multiply through, so we end up getting x squared minus 4x plus 4. We have to distribute the 3 through. When we add the 4, you end up getting this green right here. 3x squared minus 12x plus 16, where a is 3, b is -12, and c is 16. It moves up. If we look at the 3, it's a positive, so we know it goes up. We know the vertex, if we jump all the way back to the original equation, right here where the red mark is, we're looking at what makes that 0. So 2. If we input 2, you're going to be left with this 4. So the vertex is 2, 4. So if you look at the far right, we have a vertex of 2, 4. Okay. We also know that it's a minimum, and the minimum is the y value that's on that vertex of 4. And then we also know that the axis of symmetry is x equals, and it's x equals where the x is the vertex. So we got x equals 2. Moving on. Okay, conclusion. Given that f of x is ax squared plus bx plus c, and a cannot be 0. If a is 0, now we end up making a linear. We know that the parabola opens up when a is greater than 0. And then the y-coordinate, therefore, is a minimum. So we get this nice, lovely picture. We know that the parabola opens down when a is less than 0. Therefore, the y-coordinate is a max, or we get this picture. So without graphing, we want to determine if this parabola opens up or down, and whether the y-coordinate of the vertex is a max or a min. In other words, you need to ask yourself the question, what do I need to find? The basic thing you need to find that's going to tell us this is a. If we can figure out what a is, then that'll help. Here's a hint. This is part of it maybe, where the a, remember, is on the outside. Okay, but if we multiply together, so if we take our f of x and we keep the -2, if we multiply that 3x using distributive and distributing the 5 through also, you're going to get 18x minus 3x squared plus 30 minus 5x. If we distribute the -2 now, or we could simplify inside, either way, -2, so this will be -3x squared plus 15x plus 30. So we get f of x equals 6x squared minus 26x minus 60. If we look right here at the ax squared part, we know that a equals 6. Therefore, since a is 6, it is positive, it opens up. If it opens up, therefore our vertex is a minimum. Graph y equals x minus 3 squared minus 5. What's the vertex? Quickly running through this, we know that what can we plug in here to make this 0? The answer is 3. So we plug in 3. Now if we cover that out, in other words, if we input 3 again into the x, you get 3 minus 3, which is 0. So what's left? -5. Okay? So our vertex is 3, negative 5. So if I come to the far right, if you notice the table that I set here, okay, here's my x's, here's my y. Okay, right in the middle I'm going to put 3, negative 5. So there's my vertex. Okay. So the points that are going to help me graph this are, let's go 2 above, 2 below. So 2 numbers above 3, easiest ones are 4 and 5. 2 numbers below 3, 2 and 1. And then those are going to be the points that we can plug back in. So state the transformation. If we go back to the original part, if we state the transformations from the parent graph, what has basically happened? It was a horizontal shift. Which way? Well, we know that it's gone to positive 3, which is on the right, and then down. So it's a horizontal shift, right 3, and we know it went down. So vertical shift down 5. This form that you see right here, the y equals x minus 3 squared minus 5, this is called vertex form of a parabola because you can easily identify the vertex, how we've been doing it. So vertex form, a quadratic function y equals ax squared plus bx plus c with a not equal to 0 can be written in this form. Y equals a times x minus h squared plus k, where the vertex is h makes that 0, so it's h, and what's left is k. Axis of symmetry will always be equal to this x value, or h, so x equals h. If we need to take this original equation, if we go back here to the top, take this. If we are in vertex form, but I need to get to maybe standard form, so the ax squared plus bx plus c, if you square x minus 3, so y equals x minus 3 times x minus 3 minus 5, we get y equals x squared minus 6x plus 9 minus 5. Y equals x squared minus 6x plus 4. If we notice, one thing that I can do, which, again, plugging in points and helping graph, if I plug in to this and this, if I plug in 0, you get 0, 4, which basically is telling you that the y-intercept is equal to 4. So that's a point that actually helps us graph it just in case. But if we go over here on the graph, we're going to go to 3, negative 5. There's a vertex. Does it open up or down? Well, the a term, which is in front of the parentheses on the vertex form, is 1, so it's opening up. If we look at the equation we just found, x squared, it's a 1, so we know it opens up. So here's my vertex. My vertex is 3, negative 5. If we plug in 5, what we can do is 5 minus 3 is 2. 2 squared is 4. 4 minus 5 is negative 1. 4. 4 minus 3 is 1. 1 squared is 1. 1 minus 5 is negative 4. Already got the 3, negative 5. 2. 2 minus 3 is negative 1. Negative 1 squared is 1. 1 minus 5 is negative 4. And if you notice, these mirror images, so if you plug in 1, you should get negative 1. Plot the points. And then one extra point you notice was the y-intercept at 0, 4. There's our graph. And then notice, put the axis of symmetry. So if I ever had to mention about the axis of symmetry, axis of symmetry, AOS, is x equals what the x coordinate is. X equals 3. Go ahead, hit pause. Here's 3 questions. What you want to do: graph each function, describe how it's translated, and then identify the axis of symmetry. I'll see you back here in a minute. Alright, welcome back. If you notice, each one, 1, 2, and 3, I got rid of the parentheses by multiplying, simplifying, and writing them in quadratic standard form. So squaring the x plus 2, getting y equals x squared plus 4x plus 3. And number 2, you have to square the x minus 3 first, then distribute the negative 4, then simplify, and you get negative 4x squared plus 24x minus 34. And then the last one, square the x minus 3, you get x squared minus 6x plus 9. Okay, going through each one, go back to number 1. If you notice, the a term is positive 1, therefore it opens up. The A term on 2 is -4, therefore it opens down. The A term on 3 is 1, so it opens up. Okay. Next thing, from basically this red marker. So remember, the red dotted line which I'm drawing right now, that's our parent function. What has happened? The vertex. If we look at our vertex form, what goes in the parentheses to make that 0? -2. What's left? -1. So the vertex was -2, -1. In the middle, what makes the -3? X minus 3 is 3. So 0 times -4 is 0. What's left is 2. So the vertex was 3, 2. And the last one, 3 goes in, 0 left. So 3, 0 was the vertex. Forgot to write that. Okay. Axis of symmetry. It's always where your x-coordinate of the vertex is. So number 3, x equals 3. There's the axis of symmetry. X equals 3 for 2. There's the axis of symmetry. And x equals -2, which is the x-coordinate for the vertex. So what's the shift? We did number 1, horizontal shift left 2, vertical shift down 1. We did horizontal shift right to +3, up to 2, and then if you notice, it's opening down, so it's a reflection about the x-axis. And because the -4 is out there, that 4 is bigger than 1, it is a stretch by 4. And the last one, it was just a horizontal shift right 3, vertical shift down. Lastly, we need to identify the vertex, axis of symmetry, the maximum, the minimum value, and the domain and range now of the function. So if we look at it without graphing, what goes in here to make this 0? 2. What's left? 3. So our vertex is 2, 3. Next thing, is it a minimum or a maximum? The A on the outside, right here, is a 1. So A is positive. So A is greater than 0. Therefore, it's a parabola that opens up. If it opens up, it's a minimum. So we say minimum of, and then whatever the y value is 3. So minimum of 3. Okay. Axis of symmetry is whatever the x-coordinate is. So the AOS is x equals 2. Okay. Now we got to do domain. Well, remember, on parabolas, what's the domain? The domain is the set of x's such that all real numbers, and the range, the y, is based on that vertex minimum or value. Well, we said it's a minimum. If it's a minimum, that means that all the values have to be greater than that minimum. So greater than or equal to the vertex of 3. On 2, if we input -3, we're going to get a vertex of -3, 2 again. This time, notice the negative. The negative tells us it opens down, so it's a max of that y value, which is 2. Max of 2. The AOS is x equals, well, x equals -3, so that's the x-coordinate. And lastly, domain. Well, even though it opens down, it's still the set of all x's such that x is the set of all real numbers. And the range is the set of all y's. And again, because it's a maximum, our graph has to go down. So it's the set of all y's that are such that less than or equal to 2. Alright, for the last question. Now we need to write a quadratic function to model the graph. So we're given the parabola. We need to model it or write it. So the first thing, if you notice the little tally system, checklist, number system, numbers. If you notice the little, the order in which we need to do it, we need to go vertex. So the vertex is over 2 up 3. So we know it's 2, 3. So number 2, we need to plug in to the f of x equation. So we will write y or f of x equals, since it's just an equation, it's just y, equals a. We do not know a, but we do know that the vertex is 2, so the opposite of 2 is -2. And then what's left is the plus 3. So there's our starter vertex form equation. 3 says we need to choose another point that is in there and plug it in for x and y. So if we notice, kind of following the curve, we have probably the best one is this 0, 7, so the y-intercept. So let's plug in 0, 7, 7 for y, 0 for negative 2. Now let's solve. So we get 7 equals negative 2 squared is 4a plus 3. When you subtract 3, you get 4 equals 4a, a equals 1. Therefore, we can write our equation, y equals 1, x minus 2 squared plus 3. This is in vertex form, or you can actually just leave it as y equals x minus 2 squared plus 3. Congratulations. I know it was long. You're tough. You're good. Do your best. Forget the rest. Bye for now.